Hi everyone, the channel Easy Lecture welcomes you. In our previous video, we discussed the types of signals like energy and power signal, then deterministic and random signals. So we discussed the types of signals. In this video, we are going to discuss the elementary signals, and you should not confuse between elementary signals and types of signals. Elementary signals, it includes test signals such as unit step signal, ramp signal, parabolic signal. So they are test signals, and these test signals are called as elementary signals or basic signals. They do not come under the types. Okay, so here why do we call these elementary signals as test signals? The reason is to analyze the system, to understand the working of the system, to understand the properties or characteristics of a system. We give these test signals as the input to the system and study the output or the response produced by the system. And if the system produces desired response, then we can conclude that the system is performing according to its property or characteristics. If it is not, again we can study its characteristics. So for these reasons, these signals are used, and these signals are therefore called as test signals. And step signal, ramp signal, parabolic signal, impulse signal, they come under this category, and that is why we come across these words such as find the impulse response of the system or find the step response of the system. Okay, the thing is, if it is asked to find the step response of the system, it is nothing but a step signal is given as input to the system and the response is studied. Similarly, to study the impulse response of the system or to find the impulse response of the system, we give the impulse signal as the input and we study the response produced by the system. So this is the thing, and we already know the output or the response produced by the system for these test signals, and we can compare the response produced by the system with the already known responses, and if it is behaving, if it is giving the desired output or desired response, we can say the system is functioning very good, the function of the system is pakka. So that kind of conclusion can be made. So for these reasons, we are utilizing these kind of systems. Now let us get into the video to discuss further. Before entering into the video, subscribe my channel Easy Lecture. Now let us go for further discussion. So among these, the first signal, the first and foremost category is type is unit step signal, and unit step signal we know already. So for x-axis we have, so we are going to discuss the things related with the continuous signal only, and continuous signal, for continuous signal along x-axis we have time period t, and along y-axis we have the amplitude f of t or u of t for unit step signal or y. So we can take any notation, so it may vary from figure to figure. Okay, so here along x-axis the thing is we are taking the time, and along y-axis we are taking the amplitude. Okay, so for t greater than or equal to 0, the amplitude becomes 1. For t greater less than 0, the amplitude is 0. This is unit step signal. Okay, so this is the thing, and as a real time example, we can consider switching off the light or fan after returning home. Okay, so when we reach our home, so immediately the first thing that we do is we switch on the fan, and until it is not disturbed, it is still in the on position. So previously it was in 0 position. The moment, the instant when you touch the switch, at that time t becomes 0, the x-axis becomes 0, and the amplitude is shooting up to 1. Okay, so it is switched on. So that is considered as unit step signal. Okay, as a real time example, and here it is given as the notation in equation form. It is u of t equal to 0 if t less than 0, u of t equal to 1 if t greater than or equal to 0. That is unit step signal. Now let us discuss the next signal, that is ramp signal. So ramp signal, the response is a kind of ramp. Okay, and for every unit change along x-axis there is a similar unit change in y-axis. Okay, so it is changing from 0 to 1. Here also it changes from 0 to 1. When it increases from 1 to 2, it also, the amplitude also increases from 1 to 2. So here the amplitude becomes 2. Here in x-axis also it is 2. And when we extend further, here if it is 3, then here also it will be 3. So it cannot be shown here. So this is the thing. Okay, so like this the ramp signal goes. And when we want to study the relationship between ramp signal and step signal, ramp signal is the integration of step signal. Okay, so integration, this is integration. So that means step signal is the differentiation of a ramp signal. Okay, so here whenever I talk about differentiation or integration, I used to say this word. Integration is nothing but it is summation. Summation is used for discrete signal, whereas integration is used for continuous signal. So this understanding we must know. And differentiation means taking a small portion, okay, taking a small portion from the signal. Okay, so for example, if we take this much, okay, so this becomes dt and this becomes d of r of t, small portion. Okay, so this is differentiation. Taking a small portion from the entire signal is called differentiation. That process is done by differentiation, and summing up the signals, the continuous part. So that is nothing but integration. Okay. So how do we relate this unit step signal with the unit ramp signal as an integration? For example, let us see here, for a unit step signal, when t equal to 1, what is the amplitude? T equal to 1, the amplitude is 1. Okay, and for t equal to 2, the amplitude is again 1. When t equal to 1, the amplitude is 1, t equal to 2, amplitude is 1. Unit step signal, I am talking about unit step signal. When they are added together, the amplitude becomes 2 for the unit ramp signal at t equal to 2. Then for unit step signal at t equal to 1, the amplitude is 1. At t equal to 2, the amplitude is 1. At t equal to 3, the amplitude is 1. Again, all the things are added together, and in unit ramp signal at t equal to 3, the amplitude is 3. Similarly, at t equal to 4, the amplitude is 4 for unit ramp signal, which means all the previous amplitudes of unit step signal are added to reach this thing. Okay, so for a discrete signal this is okay, but we cannot use the same notation for a continuous signal. Okay, for a continuous signal we need to go for longer s, elongated s. Elongated s is nothing but summation. Instead of this one, this symbol is used for discrete signal, so we do not use this one here. We use elongated s, that is summation. Okay, summation of u of t dt is r of t. So r of t is nothing but it is ramp signal. U of t from 0 to infinity, the unit is from, the limit is from 0 to infinity. Even if it is from minus infinity to infinity, it can be broken into minus infinity to 0 and then 0 to infinity. Whereas for minus infinity to 0, the amplitude of u of t is 0, and that can be neglected, and we will be having the limit as 0 to infinity u of t dt, and u of t dt in the limit 0 to infinity, its amplitude is 1. So integration of 0 to infinity, the limit is from 0 to infinity, u of t is 1 dt. Okay, and this integration and differentiation we can cancel, both the process they cancel each other, and finally we have t. So r of t is equal to t for 0 to infinity. Okay, so that is what we have written here. Here instead of t we have represented it by the notation x. R of x is equal to x for x greater than or equal to 0, and it is 0 for x less than 0. So this is unit ramp signal. Okay, the next one is unit parabolic signal. The shape of the parabolic signal is shown here, and it should not be confused with exponential signal, because exponential signal doesn't obey this equation. So only the parabolic signal obeys this equation, and it is not necessarily to be t square by 2, it can be even 8t square by 2, and if the value of a is 1, we call it as unit parabolic signal. If the value of a is not 1, we call it simply as parabolic signal. So this is the thing, this is the difference between unit parabolic signal and a simple parabolic signal, and also this is applied to all other signals also. We can say unit step signal or step signal depending upon the amplitude. If the amplitude is 1 for t greater than or equal to 0, we call it as a unit step signal. If the amplitude is not equal to 1, we simply call it as step signal. Okay, so the same is applicable for all the other types of signals also, or the other elementary signals also. Okay, so now when we looked into the relationship between a step signal and a ramp signal, we concluded that ramp signal is the integration of step signal. Similarly, we can derive the relationship between parabolic signal and also ramp signal. So parabolic signal is the integration of ramp signal. So parabolic signal is the integration of ramp signal, integration of r of t dt, and r of t is nothing but it is t. So we can write it as integration of 0 to infinity, r of t is t dt. When we do this calculation, we will be getting t square by 2, that is nothing but parabolic signal. Okay, so Parabolic signal is the integration of ramp signal. Okay, so now we know the relationship between parabolic signal, step signal and ramp signal. So relationship between parabolic signal and step signal, double integration of step signal is parabolic signal. Okay, so these things we can derive with the knowledge that we have here. Okay, now let us go to the next signal, unit impulse signal. So a very important signal. So out of all the signals, unit step signal or simply a step signal and impulse signal, they are very important, because only for these signals we consider the step signal and impulse signal as a very important test signals to test a system. Okay, that is why we call the response of the system as impulse response or step response, depending upon the respective signals that we are giving. Okay, so here unit impulse signal, the notation is del of t. Along y axis we have del of t. So del of t, it is equal to 0 for t not equal to 0. So this is the notation for this, del of t equal to 0 for t not equal to 0. And what is the value of del of t at t equal to 0? So del of t should be equal to 1. Is it should be 1? No. Del of t should be infinity. It should be infinity. The amplitude is infinity. It goes on. The amplitude goes on. Okay. So it is infinity at t equal to 0. So when this is the case, why do we call this as unit impulse signal? We can simply say it as impulse signal. The reason is, for the del of t equal to infinity at t equal to 0, but area under that amplitude is 1. The area under the amplitude is 1. Okay, so for example, so this is similar to a probability density function. So for any probability density function, the total area under the entire curve is 1. So here also similarly in unit impulse signal, we do not have any other notation, any other part of signal anywhere except at t equal to 0. Only at t equal to 0 the signal is available. So the area under the amplitude at t equal to 0 is 1, but the amplitude is infinity. The area under it is 1. Okay, so how can it be infinity? So let us see again. So as I mentioned here, del of t equal to 0 for t not equal to 0. Okay, and let us consider a signal, a rectangular signal with its base value from -2 to 2. So that means the length of the rectangle is 4 units. Okay, -2 to 0 2 units and 0 to 2 2 units. So totally 4 units. Okay, for this rectangle to have area of 1 unit, what should be its height or breadth? It should be 1 by 4. Am I right? Okay, so this portion should be 1 by 4. That means the amplitude should be 0.25. Only then the area can become 1. Okay, this is for this rectangle. Now let us consider another rectangle which has shorter length compared to this rectangle. Okay, so instead of from -2 to 2, let us consider a rectangle which is having its base from -1 to 1. So -1 to 1. So -1 to 0 1 unit, 0 to 1 1 unit. So totally 2 units. Okay, so 2 units. For this rectangle to have area of 1 unit, what should be its breadth? Its breadth should be 1 by 2. Its breadth or height should be 1 by 2. So that means its area can become 1 unit. So 1 by 2 means it will be having a greater amplitude, and now the amplitude level at this point is 0.5, which is greater than the previous amplitude. Okay, so now like that, let us shrink the base or shrink the length. So when we shrink the length, what happens to the amplitude? It goes on increasing. And for impulse signal, there is no signal available other than t equal to 0. Other than t equal to 0, there is no amplitude at all. At t equal to 0, only amplitude is there. Okay, so what should be the length? Length is 0 minus to 0 plus. Okay, 0 minus to 0 plus. So let us understand that the length is 0 minus to 0 plus. Let us think logically. So let it be 0. Okay, and for the amplitude, for the area to become 1, it should have an amplitude of 1 by 0, the reciprocal. 4 into 1 by 4 is 1, 2 into 1 by 2 is 1, 3 into 1 by 3 is 1, similarly 0 into 1 by 0 is 0. So this is by logic we are doing this, but 1 by 0 is infinity and 0 by 0 is not allowed in mathematics. it is an unallowed notation, but for understanding we are considering this 0 into 1 by 0, the amplitude, sorry, the area under that curve will be 1, and 1 by 0 is nothing but it is amplitude, 1 by 0 is infinity. By this means we can conclude that the amplitude of impulse signal del of t equal to infinity, whereas the area under the curve is 1. Okay, so that is why we call this as unit impulse signal, and as I mentioned already, again it is a continuous signal. So continuous signal means to study the area under the curve we use integration. Okay, so integration minus infinity to infinity del of t dt. Okay, then again minus infinity to 0 we do not have any amplitude, again 0 to infinity we do not have any amplitude, only at 0 we have amplitude. So 0 minus to 0 plus del of t dt, it is equal to 1, the area under the curve is 1. Okay, so that is why we call this as unit impulse signal, and when the impulse signal is represented as in the form of continuous domain, the other name given to it is direct delta signal. Direct delta signal, we can call unit impulse signal as direct delta signal also. Okay, now for no other signal I have discussed the discrete part. Okay, whether it is a unit step signal or ramp signal or parabolic signal, only the continuous signal part is discussed, because for the discrete part the same thing is repeated, but for unit impulse signal it is not like that. Okay, unit impulse signal we call in the discrete form we call it as unit delta signal, and unit delta signal we can apply it logically. For n equal to 0 the amplitude is 1. Okay, the sample is available only at the point n equal to 0. Okay, the sample is available, so the sample, okay, the sample is available, the sample is available only at the point n equal to 0, and it is having the amplitude of value 1. Now here it is 1, clear? Okay, so this is the difference between unit impulse signal in continuous domain and discrete domain. So this understanding we must have, and to convert any continuous signal into discrete signal we multiply time shifted and added unit delta signal, and that signal is multiplied with that particular signal to convert the continuous signal into discrete signal. For example, so we have discussed already about this sampling. Even then it will be interesting to discuss it again. So let it be a continuous signal, and we need to convert this signal into discrete form. Okay, so for that what do? We take a comb signal. So comb signal, it is available by time shifting this unit delta signal and adding all the time shifted samples. So here the time shifted samples, so this is 1, this is 1, this is 1, this is 1, so all are unit delta signal but time shifted unit delta signals, and all the signals are added, they are added together to get this comb signal. So this is comb signal that we are getting, and this comb signal is multiplied with the continuous signal which we need to convert into discrete form, and the output will be like this. So like this it will be converted into discrete form. So this signal is converted into this form. Okay, so for this unit delta signal is used. Okay, so that is why I am again mentioning step signal and delta signal, they are impulse signal, they are very important because we consider them as reference signal to study the response of the system, whether it is producing a desired response or not in the form of step response or impulse response. So these signals are very, very important. Okay, now the next signal, signum function. So it is another derivative of step signal. For t greater than 0 the amplitude is 1, for t less than 0 the amplitude is minus 1. So that is given here, and here the notation used is f of x, here it is y, so both are same. Okay, this is related to signum function, and the next one is triangular function. So triangular, it is another form of, it is derived from a ramp signal, and here we have 1 minus ramp, triangular function is equal to 1 minus modulus of x for modulus of x less than 1. So modulus of x less than 1 means this portion. Okay, so modulus of x less than 1 becomes this portion, whereas modulus of x greater than 1 becomes minus infinity to minus 1 and 1 to infinity, that becomes modulus of x greater than 1, but here it is given as modulus of x less than 1. So it takes the value from minus 1 to 1, and for in this region the notation is 1 minus modulus of x. The equation is 1 minus triangular signal is equal to 1 minus modulus of x, or 1 minus modulus of t for modulus of t less than 1. Okay, so this is for triangular function. The next one is rectangular function. Rectangular function, it has the value, it has the amplitude value of 1 from t equal to minus 0.5 to 0.5. So in some books it is given as from for modulus of t less than 0.5. For modulus of t less than 0.5, the amplitude is 1, and for modulus of t equal to 0.5, the amplitude is 0.5 is given. Okay, so anyway it is not going to make much difference, both are same. So here it is rectangular signal. Rectangular signal is having amplitude in the interval minus 0.5 to 0.5. So it is having the amplitude of 1 in the interval minus 0.5 to 0.5. So that is a rectangular signal. The next one is exponential signal. So exponential signal, it should satisfy the equation e power at. So this is the difference between parabolic signal and exponential signal. So parabolic signal, it should satisfy the equation t square divided by 2. Okay, so and exponential signal doesn't satisfy t square divided by 2, whereas parabolic signal doesn't satisfy the condition e power at. Okay, again this part of the equation is very important. This a is very important. If a is greater than 0 or positive, then the signal we obtain is growing exponential signal. If a is negative, that is less than 0, we will be obtaining a decaying exponential signal, which is shown in the next slide. So here a is less than 0 and we are getting a decaying exponential signal. And the next signal is a sinc function. Sinc function is sin pi t divided by pi t. Okay, sin pi t divided by pi t is termed as sinc function, and a sinc function, it has the shape like this. Okay, so it has maximum, it is a kind of sinusoidal signal with maximum amplitude at t equal to 0, and for t greater than equal to 0 and modulus of t not equal to 0 or t not equal to 0, the amplitude is gradually decreasing, and that function is called as sinc function. And there is another signal, standard signal called sinusoidal signal. Sinusoidal signal takes both sine waveform and cosine waveform. We will be discussing those things while discussing the problems. And sinc function, there is another kind of other kind of signals also there, like a complex exponential signal and complex growing exponential signal, complex decaying exponential signal, and we can. So this is complex growing exponential signal. When opposite is true, it becomes complex decaying exponential signal. So like that, there are other types of signals which we need to know, which we must have knowledge on them, but to solve all the problems we need to have understanding on the elementary signals that we have discussed so far. With these signals we can do signal manipulation, arithmetic calculation also. We can do time shifted signal, time reversal signal, time scaled signal, amplitude scaled signal. Then we can add signals, we can multiply signals. So like that, signal manipulation and arithmetic calculation can be done among signals, and those things will be discussed in future classes. Okay, so your comments are really valuable to us. Please make your comment in the comment box if you have a comment, and don't forget to subscribe my channel Easy Lecture. Don't forget to give a like button, thumbs up, and thank you. Meet you again in another video. Until then, bye. Thank you.